Okay, so looking at the handout that you got, we are going to go over section 4.7, comparing functions, and we're going to go over transformations of functions. So, what I want you to do now, if you have two different colored pencils, or if you want to grab colored pencils from the back, that is fine. Or you could just do this all in one color. But what I would like you to do is first we are going to graph the parent function. Now, the parent function is the simplest linear function. It's f of x equals x, which is really the same as y equals 1x plus 0, which means if I graph it, the slope is 1 over 1. Pretend that's 1 over 1. And the y-intercept is 0. So we start at this first, these directions say graph the parent function using one color. So on all of these, I want you're going to get a ruler and you're going to graph on all 8 coordinate planes. There's 4 on this page, 4 on the next. You're going to graph the parent function. Now, the parent function starts at the origin, goes up 1 over 1, 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 etc. So a quick way to do the parent function is just put a dot in the corner, dot in the middle, dot at the bottom, and you draw a line. So it's basically like a 45-degree angle through the origin. So here for the parent function, I'm going to do this. Okay. And I want you all to stop the video and you're all going to get a ruler and you're all going to graph, like here, parent functions for all of these. And when you're done on this page and the back, you can turn the video back on and we will continue. So those are my parent functions. Okay, so hopefully if you're still listening now, you have drawn a parent function through all of these. Now, in addition to the parent function, we are going to draw these new functions. I'm going to do mine in a new color. You can do yours in a different color too. So now in blue, I'm going to do g of x equals x plus 3. So that's basically the same as y equals x plus 3. So I start the y-intercept at 3, go up 1 over 1, up 1 over 1, etc. And when I draw this, it's a parallel line. So this new function is parallel to the parent function. And let's compare them. So this is y equals x plus 3. And this is y equals x plus 0. So they have the same slope, but different y-intercepts, right? So I'm going to put same slope, different y-intercept. Now, what type of transformation is this? This is what we call, well, let's see if you can think of the name. I added 3 here and nothing there. So I added to my function. So whenever you add or subtract, think of the different transformations. That's a translation. So a translation has the same slope but different y-intercept. You're really adding or subtracting. And you're literally sliding up or down the y-axis. In this case, I'm sliding up 3. If you look at this one, I'm going to be sliding down 4. So a translation's when you add or subtract, when the slope is the same and you're just going up or down. So let's look at the next one. Like I said, I warned you it's probably going to be a translation. Why is it going to be a translation? Because we're adding or subtracting. And when you add or subtract, that's a translation. We're going to have the same slope, but a different y-intercept. That's a translation. And in this particular case, my y-intercept is -4, but my slope stays the same. So I draw this line. So this translation is going down 4. This translation is going up 4. They're both parallel and they slide up and down the y-axis. Okay. So those are the first two, and they were translations. Now, here I am not adding or subtracting. Here I am multiplying by a number greater than 1. So if we multiply by a number whose absolute value is greater than 1, that is a vertical stretch. And let's see, with a vertical stretch, I'm obviously going to have a different slope. So I'm going to start at 0. I go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 over 1, down 2 over 1, down 2 over 1. And this is what a stretch looks like. The blue line is stretching. What does that mean, to stretch? It means it pulls away from the x-axis. If you notice, every point on the blue line is further away from the x-axis than the red line. The red line is closer to the x-axis than anything on the blue line. So when you pull away from the x-axis, that is a vertical stretch. So this is stretching. And how do we know when something stretches? When the absolute value of the slope is greater than 1. So let's look at this next one. Obviously, the absolute value of this slope is not greater than 1. So this is not going to be a stretch. What it's going to be, when the absolute value of the slope is in between 0 and 1, that's a vertical shrink. And just like a stretch pulls away from the x-axis, a shrink gets closer. And this comparison, they have different slopes. So now I'm going to start here, go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 over 2, down 1 over 2, down 1 over 2. And here you will notice that every point on the blue line is closer to the x-axis. So a shrink pulls closer to the x-axis, where a stretch pulls away from the x-axis. And I want you to think of the parent function is right in between a hoy and a vux. So I want in your head, or right in front of me, give me a hoy, give me a vux. The parent function's right in between. So it's hoy, vux, parent function. When you pull the parent function towards a vux, that's a stretch. When you push it down towards a hoy, that's a shrink. Okay. So now let's turn the page. We've done translation, where you add or subtract, but the slope stays the same. We've done, see if I can move this. We've done vertical stretch, where the absolute value of the slope is greater than 1. Vertical shrink, where the absolute value is in between 0 and 1. And now we're going to do a reflection. So I'm going to draw the parent function. Hopefully you already have. And now I'm going to graph this new one, which has a negative slope. So if you remember, anytime you multiply by -1, it becomes a reflection. So here, the comparison is the slope is negative, m is less than 1. So when you have a negative slope, this is a reflection. And you always have a reflection whenever you have a negative slope. So I'm looking at this next one. The slope is a -3. Because it's negative, it's a reflection. Because the absolute value of 3 is greater than 1, it's a stretch. So this is going to be a vertical stretch with reflection. Vertical stretch with reflection. And the reason it's stretching is because the absolute value of m is greater than 1. And the reason it's reflecting, because m is negative. Okay, so now I start at 0. I go down 3 over 1, down 3 over 1, up 3 to the left 1, up 3 to the left 1. And here, you can tell this is stretching because it's getting closer to being a vux, but it's a negative slope, so it's a reflection. Okay. Now let's look at the last two, and the last two do a bunch of combinations. So let's see if we can come up with, write down what the transformations are first before we even graph anything. So here, because the slope is 1/3, because the absolute value of m is in between 0 and 1, that's a vertical shrink. And because we're adding or subtracting, in this case, we're adding 1, that's a translation. So these two types of transformations, it's shrinking because the slope is between 0 and 1, and we're starting not at 0. Whenever the y-intercept is not 0, it's a translation. So now I go up 1 over 3, up 1 over 3, down 1 over 3, down 1 over 3. So this is my new line, which is a shrink. And I should draw the parent function, which looks like that. Okay, now for the next one, let's think. Take it step by step. What does the negative do? The negative means it's a reflection. The absolute value of -2 is greater than 1, so that's a stretch. And the subtracting one, we're adding or subtracting, and that means translation. So this last one, we have 3 different transformations. So now I start at -1, I go down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1. This looks like this. So it's reflecting, it's stretching, and even though I kind of went through the origin, I wasn't supposed to, it's a translation too. So this is your parent function. I messed them up between blue and red, but you get the point. Okay, so we just went over that there are 4 main types of transformations. So let's just review that all on the next page. So here, okay, I took these notes for you so you can just pay attention. So there's 4 types of transformations. The first is a translation. With a translation, you have the same slope but a different y-intercept. You're either adding or subtracting. That's how you know it's a translation. So for those 2 equations, those are translations. Then here we have a reflection. How do we know it's a reflection? If you have a negative slope. So y equals -x is a reflection because the slope is negative. How do we recognize a vertical stretch? It's when the absolute value of m is greater than 1. So obviously 2 is greater than 1, 5 is greater than 1. Those are stretching, which means they're moving away from being a parent function closer to being a vux. And a vertical shrink is when the slope is in between 0 and 1. Okay, the absolute value. The reason we look at the absolute value is because it's negative. Whenever it's negative, it just means that it's a reflection. So now here, this says, okay, what do we call the most basic linear function? That is called the parent linear function, is the most basic. And the most basic one is f of x equals x. And blank is the form, so that's where they're going to say f of x equals x is the form of the parent linear function. So now we're going to compare these graphs. So I want you to think, what type of transformation is this and y? What type of transformation is this and y? Hopefully you said this is a translation down 4. It's a translation because we are subtracting. This is a reflection and a stretch. It's a reflection because that is negative. It's stretching because the absolute value of 2 is greater than 1. Okay. Now here, this says, the checkpoint says r of x equals 1/2 x. Compare that with the graph of f of x equals x. So in your minds, tell me, do you think this is a vertical stretch, vertical shrink, reflection, or translation? Well, it's not a reflection, slope's not negative. It's not a translation, we're not adding or subtracting. So it's between a vertical stretch and a vertical shrink. And because 1/2 is in between 0 and 1, that makes it a shrink. And we know it's shrinking because it's closer to the x-axis than the parent function, right? So remember, this is a vux. This would be a hoi. Parent function's right in between. Stretching goes that way, shrinking goes that way. Okay, let's turn the page again. And here, we're going to fill these in. So now, here, if you look at lines, this is the parent function. And the two other lines move up, move down, but they have the same slope. They just slide up and down the y-axis. The only thing that changes is the y-intercept. So these graphs have the same slope, but they have different y-intercepts, and we call these translations. Okay, now the next one, these graphs have they have different positive slopes. This one has a slope greater than 1, and it's a stretch. The absolute value greater than 1, it's a stretch. This one has a slope that is in between 0 and 1/2, and that's called a shrink. They have the same y-intercept but different slopes, so we call these vertical stretches or a vertical shrink. Now, when we start putting a negative in our slopes, then we know those are reflections. So this next group are reflections. They have different negative slopes. They have the same y-intercept. This is a vertical stretch. This one is a stretch. And with reflection. And this is just a reflection. This is not stretching or shrinking. It's just reflecting. Okay. So now, here I'm just going to give you a few examples, and I want you just to think. You can add these to the bottom of the page if you want, or you can just do them mentally. So I'm going to give you 3 equations, and you're going to tell me what type of transformation is occurring. So number 1, y equals 2x minus 5. Now, you all know how to graph that, but you probably never thought, how is it transforming from the parent linear function? So the parent linear function looks like this. Well, this one's going to start down here. It's going to go up and over, up and over, up and over. So this is going to be, because the absolute value of m is greater than 1, it's stretching. And because we're subtracting 5, it is translation. Okay. So let's do another one. So y equals negative 1/2 x plus 2. So the plus 2 is making it a translation. The negative is making it reflect. And the absolute value of 1/2 is in between 0 and 1. So that's making it vertically shrinking. Okay. So now, as soon as you're done with this, you're going to go into Google Classroom, and there is a Show What You Know on translations. You are now going to take the Show What You Know on translations. If you get a 10 out of 10, I will see. And if you get a 10 out of 10, then you're going to move on to the next assignment, which is doing 2 practice quizzes. That will be on the board. If you get below a 10 out of 10, you have to come explain to me what you got wrong and why you understand it now. If you really bombed it, you're going to have to take it again. And there also will be a Delta Math optional assignment on transformations if you thought you needed more review, more practice with videos and worked out solutions. So this is the end of the video. Go ahead now and complete the Google form.